This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
So a lot of software out there is usually commercial and it's for profit. There's also a nonprofit or open source software movement as well. But there's another area of software that's not really being developed, which is software that's for community benefit or that furthers democracy. And these types of software are not being developed commonly and enough to really allow communities and democracy to benefit from technology for a variety of reasons that our speakers are going to talk about today. And they're going to let you know the projects that they've been working on and how they've been able to develop infrastructure and the right contacts among people and get funding for these kinds of projects. So this should be a really interesting talk, and we're glad to have them here today. The two speakers are Todd Davies and Jerry Feldman. And Todd Davies is going to start us off, and he's from Stanford. He's been at Stanford for 26 years. He's currently the Associate Director of the Symbolic Systems program here at Stanford. We sometimes get symbolic systems majors here. So, any currently? All right. They're all watching on the video, okay. So typically EE 380 has CS and EE majors, but sometimes we do get some other majors. Todd Davies is involved with PEACE, which is the Partnership for Internet Equity and Social Engagement, and another project called DEMI, or is it DEAM? Called DEAM, which is a platform for online deliberation. And then our other speaker is Jerry Feldman, who's sitting here in the front row, and he'll be talking after. And he's a professor of electrical engineering and computer science at Berkeley, and also a member of the Institute for Cognitive and Brain Sciences. And he was at Stanford originally, so he's very familiar with this place, from 1966 to 74. And then he was at Rochester from 1974 to 89. And then since then, he's been at Berkeley. So please welcome our two speakers.
Well, thanks. I'm thinking of myself as kind of a warm-up act for Jerry, partly because my content is going to be airy-fairy, just kind of high-level issues and questions to pose for discussion. And these are issues that I've been very interested in and have tried to do some implementations around, but the real content addressing the questions that I'll raise is going to be presented by Jerry in a demonstration of his system. So hopefully what I'll do will set some context and at least share some of the questions that I have not resolved in my own mind, and probably Jerry and I have different ideas about, and hopefully that'll then give some good basis for discussion as we go forward. Title of the talk is Software Not Provided, which is kind of a pun, I guess. It would mean software that could feasibly be produced but doesn't, or that gets underprovided or tends not to be as easy to produce in the market or in the way that software gets produced as other types of software. And I found this interesting question to think about, like why do some types of software not get provided? And was trying to relate it to experiences I've had with the PEACE and DEAM projects, and in Jerry's case with his COPE project. So we came together and decided to do this jointly because we're working on projects, my DEAM and his COPE, that that share a lot of commonality. And I think Jerry and I both agreed that we'd like to make this interactive. There are going to be some points where I'll ask for audience participation and ideas because we're intending to learn from this too. But feel free to interrupt, and don't worry about the time, because I can rush through my slides to make sure that Jerry has enough time for his. So, question I want to pose to start off is, what is it that results in software actually getting produced? And in the abstract, we listed 4 different factors that contribute, that are helpful to get software produced. One is some sort of money motive, often a profit motive, but some kind of, it might be a grant or a provision of law that provides money to fund software, but something that developers and those who put in labor can rely on to get money, either in a one-time way or in a continuous stream. A second model which we see often in, or second factor which we see often in the open source world is what's called scratching your itch. So this applies to the software developers themselves. Having a need or desire for some kind of software could be something as simple as a driver to get a piece of hardware that somebody wants to work with Linux, or something as complicated as a major debugging tool, or content, or a versioning system, or something like that. But there's definitely a bias under this factor toward things which developers want, and designed in ways that would please developers, in particular the particular developer that is writing the software. A third factor which helps is if the software is easy to write. I found perversely in my own work with students that sometimes this can be a negative factor in academic projects. I find the students like to work on the software that's hardest to write, and sometimes it's hardest to get those last pieces that are rather straightforward, but that no one wants to bother to put the time into. But in general, being easy to write, I would claim, other things being equal, will be a positive for getting software produced, particularly when it's truly easy. And finally, when it's similar to something else that exists. This is very helpful because it solves a number of coordination problems in the design. Whether it's an open source or commercial project, if you have a clear model for how the software should work, what its features should be, then that really simplifies the communication task. People kind of know what they're supposed to do, and it really cuts down on disagreements, which often arise, particularly in more democratically run open source projects, in which there's an attempt to do it in an open way from the beginning when design is taking place. But there is software that doesn't have these features. There is software that doesn't turn a profit, or that no one is willing to pay money for, or enough money. There is software that software developers don't particularly desire. One of my favorite examples of this right now is usable, simple tools for building web pages. What used to be Mozilla Composer is essentially no longer supported. And I think the reason is not that it's not a useful tool for many of us who are not really web programmers, but the developers themselves don't find it particularly helpful. They'd rather write HTML or use more advanced tools for web programming. So it's not quite at the right level to appeal to developers, and therefore has sort of fallen off the radar screen, and supposedly to be resurrected as part of the new Mozilla suite, but so far not forthcoming. And that's kind of an irritant for some of us who relied on it for a long time. Software that is hard to write or to provide service for, or to maintain. So that's, I think, pretty obvious. And finally, software that's novel. If there isn't a model out there that can be clearly imported, then that really makes things more difficult. And of course, it makes it less likely that the software will even be conceived. If we believed in the profit motive as an important mother of invention, the space of possibilities of software are far from exhausted in things that get produced, and human creativity, at least in this very profit-driven society, seems less likely to be expressed when these other factors are not there. Okay, so some examples, or this kind of conceptual examples. If software is designed for people who do not have much money, or who have no money, then that is a problem for the revenue stream, and it's a problem for various models that one might envision. Advertisers are less interested in it because they are typically going to want to target people who have money to buy their products. So an advertising-driven model doesn't work very well. Obviously, a pay-for-service or commodity model doesn't work very well. In low-income communities that have underfunded governments, software that would support infrastructure like the city website can be hard to fund. So it impacts people and communities that are under-resourced in many ways, not to have enough money to pay for it. Software that is designed to meet particular needs of those who are not computer experts, in line with the, it's more likely to get developed if it's desired by developers idea. This is the flip side of that. There are many types of software that are useful to people who are not developers, and I mentioned one, a composer, and that's actually a pretty high-level tool as things go, but if we think about applications on the web, the things that people who are really under-resourced need, like tools to help them figure out how to get welfare payments, or easy tools for learning languages that don't cost money. These are things that have been underprovided. Some software that could be produced is complex, or that does get produced is complex, either in the tasks it supports or in the nature of what's needed. So again, this is the opposite of the easy software. Or software could be not already available, which would then mean that there's no model for it. So if you think of examples that fit in these categories, then all of those might be candidates for being underprovided. Just note that you see that there are no bullet points. Oops. On the first three items of that slide, and that's a bug in PowerPoint. I want to point this out because PowerPoint's a very well-funded product for which there's a large commercial need. And yeah, so just to prove my point here, there you can see the actual slide. It does have the bullet points in there. And there's nothing special done in here. I just pasted in ASCII text. So it's a bug in Mac PowerPoint, and there are many of these bugs that will probably never get ironed out.
Or you'll be able to use the new Google system.
Perhaps. Okay, so quick review. I wanted to pose some questions just for brainstorming, having defined some of the parameters here. Jerry and I are both particularly interested in under-resourced communities. So what would you say are types of software that are particularly needed by low-income or people or under-resourced communities? Yep.
You have to ask them. If you try to guess yourself, you'll get it wrong.
Sure. I mean, that's a reasonable thing to say. On the other hand, I'm trying to get you to imagine, since we're in the seminar here.
There is an example of an organization that's been feeding software into that model.
Mm-hmm.
And this is Benetech. We've spoken here a couple of times. They build systems for visually impaired and audio impaired people who use computers.
Mm-hmm.
And they also build encryption systems for people doing reporting of human rights abuse electronically in countries where simply having the material on their computer would be
Mm-hmm.
a very strong negative to survival.
Right.
And they do this with donation-based mechanism, effectively getting people who are embarrassed by the existing situation to contribute money to build
Mhm.
this software.
Yep. So that's yep.
Resource databases.
Are we capturing these? Okay, good.
Resource databases that provide information about access to benefits and charity resources,
Mhm.
or resources that are targeted at low income.
Mhm. Yeah, so these are the things similar to the types of examples that I thought of, and that I think Jerry has thought of. Yep.
Mechanisms to communicate within the community itself.
Mhm.
For example, something like FreeCycle, but for people that maybe don't have internet access
Mhm.
at home and maybe aren't able to use a website that easily yet.
What is FreeCycle?
Oh, FreeCycle is kind of like Craigslist, but for free stuff.
Okay, great.
That way the idea is that you're
Or
recycling.
barter.
Giving it away is better than just recycling it.
Mhm. Great, I should know that. No, I do. Okay, so that we came up with examples of there just as existence proofs that there are some software that are particularly needed for under-resourced folks. Yeah.
There's another interesting thought here, at least I think it's interesting. Programmer productivity varies radically, and I think it's probably 3 orders of magnitude, sometimes perhaps more. And you find occasional people who are strongly motivated to build things they think are needed. And they build things and then make them available to the general populace at no cost. The cost of a site to build things is actually relatively small at this point in time. And so as a development model, that's not such a bad idea. If you are in the Six Sigma section of the productivity for programming. There aren't a whole lot of people there, but the ones that are there make a big difference.
So these are, you're saying developer tools? Is it?
No, these are people who see a need in a different context and actually just make it.
Can you give an example?
Well, yeah. I think some of the Benetech stuff came that way originally. Beyond that, I can't think of an immediate example. Catch me afterwards. I'll
Sure. Okay. Well, all we wanted to do was convince you that there are such projects that one could develop. And since we're running short of time, I'm going to cut short the brainstorming. But think in your own minds about what types of tools non-experts might need, but experts themselves do not need. I mentioned one. Features that make software hard to write, and what software is technically feasible but not available. These are interesting questions to think about. An area that both Jerry and I have been interested in for underprovided software is what is in the literature, or falls under what in the literature has been called community computing. Software that generally supports communities, or technology that supports communities. And in particular, in our case, we're thinking of the needs of low-income communities. There's a subspecies of community computing that we've come to call community-based software, which is a narrower class of that, in which the software itself is developed by the community, not just for the community. And the community members are assumed to have control, or it's desirable for them to have ownership over both the technology and the content. And ideally, the community benefit should be the primary goal that derives the availability of the software or the technology, as opposed to some other external motive. This is a very hard, difficult ideal to realize in practice, but I just want to put it out there because it's a set of goals that I've found in my own work in Peace, the partnership with the East Palo Alto Community Network, is important to people. These characteristics are considered desirable and things that we should aim to support. Some examples of projects that fall into the community computing space. Community networks is a fairly broad term that's been around for quite a while, maybe 15 to 20 years now. And before the web referred to subnetworks of the internet or networks of computers that were generally geographically based in some town or community and would have something like a bulletin board, a system for people to communicate, in some cases before email or before internet email. And that's grown now to be any kind of system, usually on the internet, that hooks people together either in a geographical space or in a virtual space. They're usually assumed to be a geographical space, but where the assumption is that there's that the system is of the community in some sense. So I'm not going to say too much more about that in general, but an example of a community network that I've been involved with is EPA.net. EPA stands for East Palo Alto. EPA.net is a web portal in East Palo Alto that was designed as part of a community network project, which I'll describe a little bit about. Another example of a community computing, which maybe wouldn't fit the traditional definition, but I think fits or the way people have usually thought about it, but fits the abstract definition. The election incident reporting system, which was developed a few years ago by CPSR and Verified Voting to help people monitor questionable incidents that happen during elections and to report them in real time on election day in a distributed system in a usable interface. And finally, online deliberation platforms, the class of tools that Jerry and I are both working on. Just a bit about EPA.net, because this is going to be the main example I'll use to illustrate some of the problems that have occurred empirically for low-income communities. EPA.net was funded as part of a grant from Hewlett-Packard that went to the Plugged-In Community Technology Center in East Palo Alto in the year 2000. The grant included money for other infrastructure, technology infrastructure in East Palo Alto, including computer clusters, technology hubs, access points at 10 different places around the city for people who didn't have internet access in the home. And those are free access points. Also, it provided money for the development of expertise, people who lived in the community, who would work in the access points or in the technology center and learn how to assist others or to produce content for the third element, which is EPA.net. EPA.net is a web portal that still exists today. If you go to www.epa.net, you'll see that it's still quite active community website with a lot of fresh content that served the role, when it first came up, of being a town newspaper, among other things. So it was a place to go not just to read news about what was happening in town, but also to post and view classified ads, to look at the calendar of events and see what was happening. And because it was interactive and many people in the community could post, it felt more like a community site than newspaper sites where the content may be about the community, but the people who are producing the content are not necessarily ordinary residents or people who are doing it as volunteers. It was also very much, they tried in this project to make it a by the community project. The design of the website was done by a group of people in the town who proposed it, and there were actually some competitions for different logos and so on, so that there would be a lot of buy-in by people in the town. And there was a lot of modification of the underlying software, which is a content management system called OpenACS. So even at the level of software, the pieces that were necessary to make it run were developed by highly skilled programmers who lived in the community or who had some close tie to it. The funding model was this corporate philanthropy model. They also got money from a Technology Opportunities Program grant from the government, from the Department of Commerce. And these were 2 different one-time gifts to the Community Technology Center. It launched in 2002, so has been going for now 4.5 years. And I think it's fair to say that it has had a pretty big impact on the community. About 1 in 10 residents are registered members of the site, which is a pretty high ratio. And the content that's put onto EastPA.net has an unusually high percentage of community-generated content, as well as all of the infrastructure being owned and controlled by the community. They're using open source software that's been modified, and the design and all that was done by people from the community. Some challenges that I've identified with EPA.net particularly as it contemplates the next generation of the site, are the fact that the one-time funding ran out a few years ago, and it's been hard to secure follow-on funding. It's easier to get someone to give money for a new idea or the creation of something than it is the maintenance of something. And even when there's a fairly broad support for it in the community, they've found that. So they've had to kind of cobble together funding, and it's been difficult to keep going. Funding is obviously one challenge. Another challenge that I think is increasing in the web portal space is that the commercial tools that are available for a lot of interactive tasks on the web are at a level that's more and more difficult to duplicate in an open source tool, which means that they're sort of piecing together from various sources, YouTube video and a calendar tool that's hosted off-site and things like that, or that will be, I think, hosted off-site. 5 years ago, before what's called Web 2.0, the web was still a relatively primitive platform, which was a negative from the point of view of getting things done on it, but it made it easier. It was kind of a leveling influence, right? It made it easier to put something up that was roughly as good as the best that was out there. As the technology develops and the web becomes more of a computing platform, the complexity is a challenge. especially for the community-based model that we talked about. And so therefore, creating tools that, and consolidating effort to make available tools that would help keep this going, I think is a big challenge. The IRS, I think I'm going to skip talking about that. This was just, I'll say briefly, this was a project that monitored voting incidents and made an important contribution, particularly in concept, just getting people used to the idea that this would be a good thing to do, so that in the last election, and that was in 2004, 2005, in the 2006 election, there were a number of tools like this that were used around the country, and people using also just ordinary technology like their cell phones and remotely hosted websites that people could call or email incidents to that would then report them. So sometimes if the goal is to create a pilot with the concept being the important thing, then a one-time grant can be okay. And there's DEEM, which is our version of an online deliberation platform, which is going to be similar to what Jerry is going to talk about in its goals. I have talked about DEEM in other venues and actually in this room as part of Terry Winograd's seminar a year ago. So you can see the video of that online. It's linked from the presentations page on my website. And we're going to have a new version of that that we'll be demoing next month, probably at the RailsConf in Portland, because we've rewritten the whole thing in Ruby on Rails. So I won't say much more about that, other than that I think Jerry and I have experienced a lot of the same challenges, as well as some different ones, of getting this software produced. We're both working with students doing the programming, and in his case, working on top of a content management system. In our case, developing from scratch. But so that might be one kind of interesting question to talk about later. But I'm going to now turn it over to Jerry so he can talk about his project, and then we'll get together after that and open it up.
Okay, so is this now on? Seems to be, yeah, good. Okay. So, thank you. Let me see if we can get this up. Okay, and I guess, yeah, I'm the laser pointer. So, as Todd mentioned, Daniel Lee and David Thaw were both students at Cal. Daniel is now in graduate school at UCLA, and David, for his sins, is now in law school. Now, I'll put this up for you guys to read while I'm talking about something that isn't exactly the same. So this is something that came out on the web a while back. I think some of you know that in my day job, I work on neural computation and AI and things like that. And there's going to be a little bit of overlap. And this is something about, well, if you understood the web, you'd understand the brain, and vice versa, and so forth. And the title of this talk, which was obviously given somewhere else, is involving networks that are brain, networks, computer networks, and also social networks. And it arose because some years back I managed to unload all of my administrative responsibilities. I had been department chairs and stuff like that, and decided that the energy should go to, as best I could, applying what I knew and knew how to do to some sort of general social benefit. And I thought about that and came up with your conclusion, which is I had no clue what people needed, but they did. So that what I should try to do is work on something that would make it easier for groups of people to work together to do whatever it is they wanted to do. This has proved to be much harder than I thought, and so I'm going to tell you a little bit about why I think that's true, and also about, sort of what we have done, and some, as with Todd, some of the challenges that remain. So you can see here on the bottom, a nice little throwaway line here. I guess this died. That, well, hey, networks, you understand one, you understand them all, sort of. Okay. Now, while you're reading this, so what happened is, like good academics, we, that is the students, and I actually had more students working on it, did a literature survey. Oh, and we also were involved at that time with a very good and savvy political scientist at Berkeley, Steve Weber, who's fairly well known in the software community for this book he wrote called The Success of Open Source, looking at all the motivations for open source. And so Steve was involved in this, and we all went looking for any software that existed that would achieve this set of goals that we had. Okay, and the set of goals was basically somehow allow people who didn't have money and didn't know how to build software, nonetheless, to use the web to work together. Okay, so this is community of practice is the kind of technical term for that, and the system that we built is called COPE, for Community of Practice Environment, and it's there, and depending on how the timing goes, we'll probably play with it a little bit in a few minutes. So, so this is again, playing academic, this is a definition of network where the emphasis is limited communication. So for my purposes, and I think for the purposes of the discussion, if we're all sitting in the room and we can shout at each other, most people and I wouldn't consider that a network. It's a group, okay, etc. Similarly, shared memory computers are not networks. If there's a lot of bandwidth and a lot of shared memory and so forth. When we bring in the brain, which I'll do a little bit, I'm sure most of you know, there's nothing vaguely like a shared memory in the brain. The brain has got this, 100 billion neurons, and they're all active, and there isn't any central processor. But there is an idea of shared context, which is attention. And that turns out to be one of the reasons that you can have all these 100 billion neurons and still sometimes act coherently. Okay, now, here's the most interesting intellectual point that's come out of this, at least for me. There's now, if you think about it right, a lot of evidence that it's actually inherently hard to get coherent action from a network. Okay, so for example, this is a systems seminar that Google runs huge server farms, and there's lots and lots of parallel computing, but in fact, there's virtually no parallel computing on a task that isn't it's broken up into parallel things. So if you want to do something big and coherent in parallel, you essentially can't. And there are even some theorems along these lines. There are things that can't be parallelized. Similarly, from neural computation, first of all, we know that the brain is massively parallel, and there's some theories, actually some developed in this some in this building, certainly some across the way, that said, well, look, we know that the brain uses these massively parallel representations, that it's kind of a hologram, okay? This is demonstrably false, and it's been shown to be false, and it doesn't work, but it doesn't work for an interesting reason, and it's because if it turned out that the wisdom, the knowledge about something, were distributed over, let's say, 1 million units, okay, there's no way to coherently convey that to another part of the brain or another part of the system. If it really requires all 1 million units to capture what's going on, it can't go anywhere. Okay, there are various other reasons why this just doesn't work. And at a social level, there's somebody, I forget who, someone's iron law of hierarchy in the sociology world which says that no matter what kind of organization you start with, you're going to wind up with a hierarchy. And not necessarily an oligarchy, but yeah, no, a hierarchy. So, and this is also true in computer networks. It's true. Basically, there are bottlenecks that if you wanted to have n squared, if you wanted to have every computer in the country communicate directly with every computer in the country, you can't do that. Okay, so there are inherent communication bottlenecks as far as we can tell. That this is true socially, it's true in the brain. So what we set out to do was not doable, which one reason why it's hard. But nonetheless, that's what we set out to do, is to build a system that would encourage communities of practice and met all the criteria that Todd talked about. So we have one, it's on SourceForge, and we've had some experience with people using it, mixed success. And I'll explain to you sort of why the success is mixed. But the goal here was to have software that essentially anybody could use. The model was something like eBay or whatever. There doesn't seem to be any serious barrier for someone who wants, certainly someone who wants to buy, and even people who want to sell, if they're motivated, seem to be able to do that. So we would hope that people in groups that wanted to work together would, with a tool like the one we're developing, say, oh, this will work, we can do this. And it's freely available, et cetera, et cetera, et cetera. Okay, and so I'm going to tell you a little bit more about the background for this, and then I'll talk about the system. And as I said, if we'd like to, we can probably bring it up and play with it. It could be crashed, but a while ago it was working. Okay, so again, I'm sure you all know that there's a lot of social networking on the web, huge amounts. And also this Benkler's book is the standard one. He's also a law professor at Yale, talking about externalities and all sorts of ways in which magic is going to happen through network activity. And certainly young people, a lot have built a significant amount of their social life of a kind around this community action. The interesting thing about it is none of these networks actually do anything, okay? And now occasionally there'll be a one-shot thing, there'll be a rally, let's all show up and do something, that works. But if you want to try to take one of these networks and try to do any ongoing thing, let's work together to come up with a plan for how the, whatever it is, energy should be saved or something, okay? So, and if you think about open source software, it's not democratic at all. All the projects I know of are very highly organized and hierarchical. Often they're volunteers and stuff, but your position in the hierarchy depends on what you can do and who gets approval and who can commit. So it seems really hard. On the other hand, it's democratic collaboration that I'm most interested in. And there are tons and tons of democratic collaborative efforts all the time. So clubs and boards, communities of practice, the kindergarten teachers of Palo Alto have lots of things in common that they could share about lesson plans, what kind of problems, et cetera, et cetera. There's no reason why there isn't a community of practice online for the kindergarten teachers of Palo Alto and every place else. But there isn't. And furthermore, as far as we can tell, there's approximately zero software out there to support any kind of democratic collaboration to actually get something done. Yeah.
So how would you deal with, how would you place MoveOn in the hierarchy of things here?
Okay.
It's basically a political action group.
Right.
It gathers money, it sets agendas, and has been extremely effective.
Yeah, it's extremely effective, but what they do is they have, it's not by any means democratic. That is, there's a set of people, a small set of people, who control it, set the agenda, and then they have a constituency, and they do have referenda. Okay, but if you said, let's have everyone in Move On try to have a general discussion of how, what we should do next, it would, as you know, this is the flaming on news groups and stuff. It just doesn't work. So they have, I agree, it's extremely effective, but it's not fundamentally democratic. There's a set of people setting the agenda.
Right, but they use a town meeting-like mechanism, geographically distributed, to effectively sort on issues, and then they get propagated out to the upper community.
Not town meeting. So they raise issues, and they have, and they, you can send to them, but I can't send to General Move On membership.
That is true.
Okay.
So you do get to know the people in your immediate.
Well, you might, but yeah. So you could have cells. Yeah, and I think that's a good thing. Yeah.
What exactly is your definition of democracy in this case?
Well, I don't know about exactly. Democracy is one where all the members of the group have an equal say in what's happening.
That doesn't scale.
I'm sorry?
It doesn't scale.
It doesn't fail.
It doesn't scale.
Scale. Indeed, it doesn't. That's completely true. It doesn't scale. What's interesting is that, for the reasons we've discussed, it really doesn't scale.
The previous
But-
slide had a bullet that said just that.
Yeah, but that's okay. But what's interesting is how hard it is to do with 10 people. It's completely clear that it doesn't work for 1,000 people.
Hard to do with 2 people.
It's,
And I wonder to what degree is intentionality involved in that? It's one, most of the most successful online projects have occurred spontaneously. Many of the open source projects have been assembled around 1 or 2 individuals who initiated something, and the rest has arisen quite spontaneously.
That's not what I would call spontaneous. That's this Six Sigma kind of charismatic figure. And of course, most religious movements, lots and lots of movements have this character of a charismatic.
Non-democratic in your.
Oh, absolutely, yeah. That doesn't mean it's ineffective. Okay, that's a different story. But the point is, if you take like the board, okay, and one of the things that Todd brings out in discussing these things is in community organizations, the meetings are normally synchronous and they're controlled by whoever shows up. Okay, that's profoundly undemocratic. And these tools provide the opportunity to make the meetings asynchronous. There's no reason why, a meeting needs to be synchronous. And then to have an actually democratic decision about, whatever it is, the community, the group, the.
I think your definition of democracy is a little distorted.
Okay.
Democracy isn't everybody having an equal say.
Okay.
Democracy is the right of dissent and the right to be fairly heard. It doesn't mean that you have to get everybody's agreement before you do anything.
So God came and told you that?
No, no, that's just.
That's your definition.
Perhaps it's my definition.
Okay.
I think it's founded on good precedents,
So
though.
the point is, that a democratic country, okay, we've agreed that, town meeting, direct democracy with everybody participating doesn't scale. It absolutely doesn't. That's why there are republics and representative democracy, all that stuff. What I'm interested in, within the scale for which it could work, there are communities of practice. So the people who play the bassoon, okay, in the Bay Area probably all know each other and have a community of practice. But the communities of practice, and they're also very productive communities, like any large architecture project nowadays is done internationally with a web-based, it's all online. And so people know how to be productive using web-based tools. As far as we can tell, people don't know how to be democratically productive. And that there are a large number of groups, institutions, things that haven't formed yet that should be able to do that.
So does your definition of democracy deny individual initiative?
On the contrary. I mean, basically, if you're in a group and you have an idea, you bring it forward.
But you can't act until you have...
Well, you can't act for the group. You can act on your own. Yeah.
The scaling issue is interesting.
Yeah.
Any number of people can vote on something. I mean, that
Right.
scales.
Right.
But the bottleneck is who can bring things forward to be voted upon.
No, it's worse. It's worse than that. It's who can. If you want synthesis, so if it's just a discrete question, it's not a big problem. So let's imagine instead of just deciding something, we want to actually do something. We want to design the system. So we would like, this is a group of reasonable size. We would like to together design what this online deliberation system should look like. So that's more like the model of what I have in mind. Not just deciding something.
That's a collaborative model as opposed to a democratic model. I mean, consider the distinction between operating under Robert's Rules of Order and operating in a committee of the whole, if anybody understands that anymore.
Yeah, but my point here is what I'm interested in is a collaborative model, but the collaborative models that seem to have worked so far seem to be hierarchical. That is, someone, and you divide this up. Now, it may be that that's inevitable, but then it does raise questions about all these things, club, board, communities of practices, etc. Now, here's an example where it's been very nicely done is program committees. So there's now software, most of you guys know this, there's now software that is pretty much available for how to organize a program committee, which is basically normally democratic. There's an issue about what papers do we accept, and it's usually voted on. And you delegate people to do various pieces, but anyway. And all of that's extremely clean, but it's very special purpose. And the claim is that you should be able to make something similar to that that's available for any of these things. That's what we would like to do. Yeah, Dennis.
Have you looked at the work that's been done at MIT on getting consensus in groups in which there are broad disagreements? Basically, it's a single document approach where things are required to be written down and then shared and modified, and then the documents merged, and issues don't exist unless they are written clearly and
yeah, well, as you'll see, what we're doing has some of the same aspect to it. So it's all document based. Okay, and the fact that it's asynchronous and online is first of all a requirement because you can't assume that the participants can actually physically get in the same place at the same time. But it also follows that it has this character of it doesn't exist unless it's been, actually laid there for everybody to work on and stuff.
Now, in the recent past, I've been working with a group that is worried about land use planning in a rural context.
Okay.
And we put up a collaborative mechanism whereby individuals could express their opinions, and we could go to a single document which captured those opinions. Mm-hmm. And precisely 0 people participated. The ability of people who are non-computer literate, to a fair degree, to participate in anything of this sort was, they didn't. They were frightened. They were scared to put their opinions out.
All those things.
Yeah.
So this is the things Todd was starting off talking about. All those are the kind of challenges.
That's right.
Yeah, so that's all there. So this is, we sort of talked about that. This is what Dennis was just saying. And the most interesting thing, I think, is the last bullet point, which is there are an enormous number of potential communities of practice which don't have any way currently to find each other and do something. I mean, again, the social networking works. There's an adult version of this whose name I forget right now, where you, instead of dating, you try to find people with common interests. but it actually is just the inverse of what I've been thinking about. So it's something which helps you find people who in your physical location that have similar interests, and then you hook up with them physically. And that's fine. Okay, it's a fine thing to do. But the thing is, can you do the opposite, which is to find people. Now, there are some, like there's support groups for disease and stuff like that. There are some very effective communities. But again, they're not actually communities that are producing anything. I mean, they give each other support and stuff like that, but they're not actually trying to, as a community, do something. And we've done a number of installations of this, which I probably won't talk about. So let me at least briefly go into what the system is, because I said we have one up and it's on SourceForge. I think these desiderata are pretty clear. Work project stuff. Institutional support, what I mean here is that the system itself can serve as the foundation for a group. So it has, databases and search and stuff like that. So a group could use the tool itself as the institutional history. So far we've had, let me cut to the chase here and then I'll go into detail. So we've had a number of these that sort of worked. We've had none that stayed working over time, and I think there are two main reasons for that. There's the fact we all talked about that it's a social problem that no one knows how to solve. But there are two technical problems involved. One of them, and I think the main one, is software rot. So the problem is you can build something these days, and I have slides on this which we may or may not get to. Anything that's on the web is subject to attack. There's spammers and all sorts of people and institutions that are going to try to break it, and no matter how benign and innocent your thing is, you're going to get hammered, and we got hammered a lot. And as a consequence of that, there's constant adaptation. So we based this thing, as Todd mentioned, on Plone, which is quite a nice system, but Plone is undergoing constant change. And so I would say a major technical reason why it's hard to do something like this is you can't just do it. You actually need some sort of ongoing support, and the funding isn't going to give you that. So that's a major I have no idea how to solve that. So even if you built this thing, and let's suppose the one we built is good, we don't have a way to keep it up. And I have no idea how to solve that. So I think that's the main problem. The other technical problem is this fact that if it's open, then it's going to get attacked. And if you want to provide this, and these things are inherently interactive, so you can provide something in which there's very, very tight control over what people can do, but that's sort of defeating the purpose. So there's some non-trivial technical problems as far as I can tell. Just like you said, it's document-centric. These are some examples of documents that you might have. This is the Plone link. I assume we can have all these slides online and stuff like that, right? Yeah, so I'll send them, and actually they're here on Todd's computer. Okay, and then there's some things about what it's not. There's an idea of workflow. The fundamental thing is going to be voting on documents where, crucially, there's a coordinator. It's called a coordinator because there isn't any particular management power. And one of the things that we're planning to build in is a kind of transparency, in which everyone can see what the coordinator does. Because as Stalin knows, if you control the secretariat, you can run everything. And so if the organization involved is one which is contentious in some way, there's real politics involved, You still need a coordinator, but you also, according to us, need this idea of transparency. So what we're trying to do is build a system that is easy to use, that non-experts can use, and has built into it the kinds of facilities and protections that you would want to enable communities to work together. So these are some of the configuration parameters. This is about Deem. Probably the nearest commercial thing is this, again, this will all be online, this BFCW thing, which I don't think is used much in the States, although it's used a lot in Europe. And it's a lot there are big commercial ones. You can, Microsoft and so forth, have huge project management things. But A, they're hierarchical, B, they're expensive, and C, they seem to require sort of like SAP or something, that you buy into tons of consultants and stuff to let you use it. But I think, as far as I can tell, this one is, you have to pay for, but you can actually use. This is the openness risk, which I talked about, short stability, demo. So we're now at 5:25. Probably too late to do that, but people can decide.
We can go about 5 minutes over.
Okay. Now we're going to have a little democratic thing here. We have two choices. We can either open up the discussion, Todd can come back up and talk about general issues, or I can do a little bit of demo. Okay? All in favor of discussion? All in favor of demo? Demo wins. See? Just like that. Okay. Now, let me see.
Most of the audience didn't participate, I'd like to.
That's another problem, but Todd, I may need your help. We had it up on your
Just go down to the bottom and get Firefox.
Oh, okay. I was looking for a Firefox. There. What?
You have that.
Oh no, but I think that's actually a Firefox. Oh no, you're right. What I was thinking is I had, and I may still. Yeah. So I have it here in my history, supposedly. Okay, so there we are. And so several of you guys have laptops. And if you'd like, you can go to this website, which is just http://cope.ixc.berkeley.edu. Okay, so it's up there on top. You can Google COPE. That won't quite work. Do COPE in Berkeley. There are other things called COPE. So you can do a search engine. And while you're doing it, I'll tell you how to log in a minute. But, I'm logged in, I guess, as Stanford 3. So the way if you want to log in, how many people want to try to log in? Anybody? Okay, you're number 1. Anybody else? 2? Okay, let's just do the 2. So your login is like I'm logged in as Stanford 3 lowercase. Okay, you're Stanford 1 lowercase. And you too. And your password is this room lowercase. So it's Gates BO1. Okay, so you should be able to log in. I'm going to log out for no terribly good reason. Okay, and let's say log in. Let's see if I could spell. Now the idea is that this supposedly is self-explanatory. Okay, so if you can read up there, the idea is that we tell people this is this site and that you should be able to go here and find background documentation. So in theory, it's all self-contained. And what I'm going to do next is first go to documentation. there's a member's guide and a coordinator's guide. Let's do a member's guide. Let's do voting. I think we're going to do, I'm sorry, we could do voting, but I think, what did I say I was going to do? Yeah, I guess I was going to do voting. Voting on a document. Okay, so what should happen is in this window it tells you how to do this document. But we're going to vote item box on the bottom right below. So if we click there, there should be some votable items because I put one on yesterday. It says voting is over, but it's not. Don't worry about it. Okay, so you should read this, and if you read the instructions, hopefully, even though none of you know how to use computers very well, you can read this and expect that there'll be something you can vote on. And the way you do that is you click on this, and that comes up as the thing to vote on. And you can also add comments. So we could look at a comment that someone, so you could have discussion. We don't have time for that now. But there is somebody's comment. And then you can comment on a comment and all this sort of stuff. But what we're going to do is vote. Those of us who are, did you guys get logged in?
Is it Stanford 1?
Yeah, Stanford 1 should work for you.
It says, and the password is this room, lowercase?
Lowercase, yeah. Gates B01. Anyway, the point is, if you do get logged in, you can vote. And we don't have time to go through this in detail, but what we're going to vote on is the GUI design. Okay, so we pulled out a document that describes the GUI, and it's a kind of trivial exercise. There's a question about, do you like the GUI or not? Okay, and so I'm going to vote, and it'll give me a voting box, and I either approve or I disapprove. It'll come as no surprise that I approve. I can submit my vote. And I also can look at the voting results. And I have to scroll down a little bit. But, so I voted, I tried this, I logged in as Stanford 9 yesterday to see if it worked. And I voted in favor of the GUI design. And I just voted for it again, in the best democratic tradition. And so... Right. So you vote down?
Yeah. I don't know if it may show up.
It should show up. I guess I'm going to have to ask again. I don't think it actively polls, but let me go.
Maybe refresh it.
It may well.
Somewhere in the 5 rows of toolbars.
Okay. Anyway, so again, we don't have time for a lot of this, but it's there. I encourage you to play with it. We've had maybe 10 different groups use it with reasonable success, including groups that weren't at all savvy and groups that were extremely savvy. So I actually was department chair in cognitive science at one point and ran all the faculty meetings using this. And I'm sorry?
You made them use it, right?
No, they could choose not to participate, right? Yeah, right. Anyway, but and it worked. But the next person took over as chair, and of course, it went away again. So I think we're done. And if there are any quick questions for either Todd or me, let's do that. Again, we'll put all the slides online, including some ones that we probably didn't get to. And both Todd and I would welcome and invite people who are interested to get in touch or tell us wonderful things we don't know about that we should, etc. Questions of any kind?
We just have a short time.
I think we did it.
No, let's just do it. And we'll
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.